Good morning, Mr. Michael.
Good morning, Alex. How are you?
Pretty good. How are you?
I'm good. All right for today?
Yeah.
Awesome. Well, today we're going to learn about area.
Cool.
And after today, hopefully you'll be able to find the area of a floor and help your family, I don't know, maybe refurbish your flooring.
Oh, that's awesome.
I know.
I want to do something like that in the future.
I'm excited for you to learn this. Oh, cool. Well, we have a video that we're going to start off with. And we're going to start like halfway through the video because the first half was kind of boring. It starts to get fun at this point.
Alright, so for our next scenario, we're going to join a street artist named Craig, who's painting a mural on the side of the building that's 15 feet long and 10 feet wide. And what we want to find is exactly how many square feet he's going to have to paint in order to complete the mural. Now the key info here is that the length is 15 feet and that the width is 10 feet, and that we want to find the number of square feet he's going to need to complete the mural. This should let us know that this is an area question, so we have to use the area formula because we want to find the inside of the rectangle and not the outside. So the length is 15 feet, the width is 10 feet, and again, using the formula, I multiply length times width, 15 times 10 is equal to 150, the number of square feet that Craig will have to paint to complete the mural. Now we're ready for a more advanced example.
Quick little snippet of the video.
Yeah.
So, much like Craig, we're going to be working with a rectangle that is 23 feet by 12 feet. And we're going to pretend that this is a flooring of a room, not a wall to paint a mural. If you want to, you can, but floor is just easier to deal with. So, I'm going to put up the screen, and we are going, I'm going to put up the screen. I am.
What?
I'm sorry.
It's okay, I don't know how it's a meeting here, but they probably just didn't put on the schedule.
No. Well,
It's okay.
okay.
I hope this goes well.
Me too. Okay, class, let's get back to what we were talking about. Awesome. So, these are all the different strategies that we have talked about before. Now, Alex, can you tell me about the area model?
Yeah, so similar to Craig's demonstration, that box right there is divided by the length and the width. So you have 12 different rows and 23 different columns, which equals your total of 276.
Good job. Now, what can you tell me about repeated addition?
So repeated addition, you write 23, 12 different times, and you add them all up, which equals 276.
Yeah. Now, traditional method. Do you remember this one?
I don't remember this one, actually.
Okay, so let me walk you through this, and then we can figure out, we already know the answer, but we can figure out how this strategy works. So what two numbers are we working with?
23 and 12.
Okay. Now with traditional, we always start with the ones column,
Okay.
and we multiply it up and across.
Okay.
So what would we do first?
So 2 times 3,
Which is?
6,
Okay.
and 2 times 4. 2 times
2
2
times
is
two.
just 4.
Okay, good job. Nice catch. Now, since we're working with the tens column now, we have to put a placeholder here. Do you remember what we put in the place for a placeholder for tens?
0.
Okay. Now, we multiply it across and up.
Okay.
So what would we do?
1 times 3, which is 3. And then 1 times 2, so 2.
And then you remember what we do to find our complete answer?
We add them up.
Good job. And then how?
Straight down, so 6, 7,
Yeah.
and 2.
Perfect. And does that match the rest of the numbers?
It does.
There you go. Cool. Now last, I feel like you like this method. So
I do.
Tell me about this one.
So, what you do is, of course, you write 23 and 12, and then you divide the square into 4 sections and divide each section in half, or half.
Okay.
So, for the first one, you would do 1 times 3,
Yeah.
which is 3, but you have to put something in each square. So if there's 0, 3, correct?
Yeah, because what goes in the top half?
The tens place.
And since 3 is only in the ones, there's no.
So you just leave it at 0.
Mhm.
And then you keep doing that for each single box. So 1 times 2 is 2.
Okay.
So 0 and 2, because 0, there's nothing in the tens place as well. Now, yeah. And then that's your answer right there, the 276.
And how do you get 276?
So let's see, you add the numbers in this direction.
Yeah.
So 6,
That looks like a 1.
3 plus 0. It's okay, Mr. Michael.
We all mess up a little.
And then you do 3 plus 0 plus 4, which is 7. 0 plus 2 plus 0 is 2. 0.
Yeah. So that's your answer. Equal group.
So, for equal groups, you do 12 different circles, and in each circle you draw 23 different dots. You add them all up, 276.
Yeah. Erase.
Arrays, you do 12 different rows with 23 circles in each, so the length times width, which is 276.
Can you notice any similarities between arrays and any of the other models that we have showed you?
Yeah, with area model.
Mhm.
So yeah, pretty much you're just doing 12 different things with 23 in each place.
And would you say that equal group is similar to?
Yeah,
You have
it
12
is.
groups with 23 in each.
Mhm.
Now, the last one that we have to talk about is the box question method.
Okay,
So, I am going to give you a little worksheet.
all right.
It's not really a worksheet, it's just guided notes. Yeah. So you can follow along as I talk about it.
Okay, thank you.
And a writing utensil might be helpful, but didn't think that far.
I can get one, Mr. Mike. We can just use that one.
Farmer's trees.
Cool.
So, we draw a box, right?
Mm-hmm.
Okay. Now, do you remember what we do with the box?
Divide it into 4.
How do we divide it into 4?
So you draw one line down the middle and then across.
Okay. Now, we're working with 23 and 12.
Uh-huh.
Well, we have 4 different places to put numbers. What numbers do we put there?
The 2, 3,
Okay, so 2 and 3.
and then 1 and 2.
1 and 2. Now, different from the box, different from the lattice that divides the boxes into half. This one is different. We have to separate the numbers into the different components. So 23 is a 20 and a 3. So we put 20 and 3, and then 10 and 2 is 12. So we have 10
Oh,
and 2.
okay.
So we don't split the boxes, we split the numbers.
Okay.
And then same thing with the lattice, we multiply across. So 3 and 10.
30.
Good job. I can write it down. 20 and 10.
200.
Mm-hmm. So it's 2 and 3.
6. And
220.
40.
Now, to find the completed answer, what do we do? What do you think we do?
I think you add it straight. Do you add it across like we did for that?
It's a great question. So we can add across.
Uh-huh.
Let's see what happens. So across.
No, like we did for this one. So diagonal, sorry.
So you want to add that? Okay. So we would have
6, 70, and 200.
yeah. But that's 3 separate numbers, so what do we have to do next?
You add those numbers up.
Okay.
So you do
So we have 200 plus 70 plus 6.
So you do straight down. So it'd be 6, 7, and 2.
Awesome. Now that looks like the same number to me as all the rest of them.
So it's correct.
Good job. Now an easier way, instead of just adding diagonal, which is a good skill to know, if we could just add them all up, which you basically did, you just combined these two into their own step, and then you did the rest of it.
Okay.
But to take a step out, just add them all together.
All right. So 200 is 30. Is 230 plus 40, 270 plus 6, 276.
Exactly.
Right.
So, do you think you have a pretty good grasp on all of these?
I think so.
Now, do you notice any problems with some of these when you get into bigger numbers, like 23 and 12?
maybe drawing the dots 276 different times.
Yeah.
So, yeah.
So which one could you use for smaller numbers? Well, yeah, which ones could you use for smaller numbers?
I mean, you could use arrays for smaller numbers, area model as well, equal groups for smaller numbers.
Yeah. Could you use repeated addition for small numbers?
What now?
Could you use repeated addition for smaller numbers?
You could also use that one, yeah.
Now, which ones would you personally like to use for bigger numbers?
I would personally do lattice or box clusters.
Okay. See, I was raised using traditional, so I'm used to that one. But whatever works best for you, I would suggest doing.
Okay.
Now I'm going to put your knowledge to the test.
Awesome.
We are going to give you a worksheet
Okay.
with a box that is 12 feet by 16 feet.
Okay.
Now you can use whatever strategy you want, and you can look in the board for references if you want. And if you need help, you're more than welcome to ask for some, and I'll gladly give you assistance. But yeah, try your hand at the worksheet, and let's see where it goes.
Okay.
So what method are you going to use?
I am using the box cluster.
Okay. Can you talk me through the steps out loud?
Yeah. So I drew the box, of course. I divided it into 4 equal parts. And so then I did 10, 2, and I did 10 and 6. Correct?
Yeah.
All right, so now I'm multiplying. So 10 times 2 is 20. 10 times 10 is 100. 6 times 2 is 12. And 6 times 10 is 60. So if I add all of them up, I get 160, 180, and 192. And that's my answer.
Perfect. Awesome. You really have a good grasp on these concepts.
Awesome. Thank you for teaching me, Mr. Michael.
You're welcome anytime. Should we end it here?
Yeah. Good job, man.
Thank you. That was
You rolled this shit smooth.